Hello and greetings to Madam Liza. My name is Yazli and this is my mini project for the subject ECE 431, Computer Programming. This project is titled System Failure Rate Estimator and it aligns with SDG 9, Industry, Innovation and Infrastructure. This program helps industries or engineers evaluate the reliability of machines by calculating the failure rate and mean time before failures or MTBF based on operation history. This mini project was prepared by me, Muhammad Yazli, Muhammad Harith, and Muhammad Amirul Nizam. The main objective of this project are to allow users to input or load machine failure data, to calculate failure rate and MTBF, to compare machines based on reliability, and to generate and export reports for documentation and maintenance planning. This program includes the following features: a menu-driven interface, user input and file loading from CSV, formatted output of failure rates and MTBF, machine comparison and sorting, and also a report generator that saves result to a text file. This project applies the following core C++ concept: classes and objects, functions and modularity, vectors for dynamic storage, formatted console output, file input and output, loops, conditions, and basic sorting logic. These skills align with CLO2 and CLO3 for this subject. We use a class named machine data to manage data for each machine. The class holds name, which is the machine name, total operation, which is the number of total operation, failures, which is the number of failures, and operating time, which is total time the machine operated. It also contains two private variables, which is failure rate and MTBF. These are calculated using the method calculated reliability. So for the function calculate reliability, this method inside the class perform the main reliability computation, which is failure rate, which is failures divided by total operations, and MTBF, which is operation time divided by failures. If total operation is 0, failure rate is set to 0.0 to avoid division by 0. Same goes to MTBF when there is 0 failures. This function is called automatically every time new data is entered or loaded. It ensures that the values are always up to date. Clear screen, it is to make the interface cleaner. We use the clear screen function. It uses system CLS to clear the console window every time the menu is shown again. And for the pause, after each operation, the program calls pause, which shows press enter to return to main menu. It then waits for the user to press enter using cin-get. Before that, cin-ignore is used to flush any leftover input. This to make user interaction smooth and controlled.
Assalamualaikum and good morning. My name is Muhammad Amirul Nizam bin Abdul Razak. My metric number is 2024783387. This is my C++ mini project presentation for subject ECE 431. I will start with the first function, which is display menu. The purpose of this function is to show a clear and user-friendly main menu every time the program runs. I structured the function using multiple cout statements with slashes and spacing to create a simple interface. The title machine failure rate is entered between lines to make the output look more professional. Each menu option is listed using cout and ends with end. To move to the next line, I keep the function simple and clean by not using loops or condition, since the menu does not change. This function does not return anything, so I use the void return type. Overall, display menu makes it easier for user to choose action in the program.
Is the enter data function. The enter data function handles manual data input from the user. It prompts for name, total operations, number of failures, and operating time. It calls calculate reliability to process the input. It also stores the result in the machine's vector. This function uses cin-ignore to clean the input buffer and getLine to accept string input properly. It's simple, interactive, and also beginner-friendly.
Assalamualaikum. My name is Muhammad Harith bin Wahab, and I will explain the function of load data from file. This function reads machine data from a file called machine CSV. It starts by opening the file. If the file cannot be opened, it shows an error and stops. If successful, then it skips the first line, which is just the header. For each line of actual data, it spreads the values using commas like machine names, total operation, number of failures, and operating times. These values are then converted into the correct data types. Once data is ready, the function calculates the value, the failure rates, and MTBF for the machine and stores everything into a list. After all the data is loaded, it closes the file and tells the user data loads successfully.
Next, I will explain the display result function. This function is used to display all the machine data that the user has entered or loaded. I structured it using an if-else block. If the machine vector is empty, it will print no data available. If data exists, the function prints a table with 4 columns: machine name, total operation, failure rate, and MTBF, which is mean time between failure. To format the table neatly, I use ZW to set fixed widths for each column and left to align the text. I also use separation to control decimal place. For example, I use 2 decimal place for failure rate. Inside the for loop, I use a range-based loop for const, auto, and machines. This makes the code cleaner and easier to read. To calculate the failure rate in percentage, I multiply by 100 when displaying. Lastly, the function prints a closing line to complete the table and call pause so the user has time to read the output. The format I use in this function is important because it makes the output easier to read and more suitable for comparison.
And the compare machine function. It compares all machines based on mean time before failure, which is MTBF. It makes a copy of the data and uses bubble sort to sort them in descending order of MTBF. We didn't use include algorithm library function to keep the logic simple and beginner friendly. It then prints the sorted list in the table format, so users can easily identify which machine is the most reliable.
Next is export report function. This function writes all the machine data into a report called output results. It first opens the file. If it fails, it shows an error message. If successful, it writes a nice report with headings and then lists its machine names, failure rate, and MTBF into format table. When all data is written, it closes the file and tells the user that the report was saved.
Finally, I will explain the main function. This is the heart of the program where everything starts. I declare a vector machine data to store all the machine entered by the user. I also create an integer variable choice to store the user's selection. The program uses a while-through loop to keep showing the menu until the user chooses to exit. At the start of each loop, I clear the screen and call the display menu function. Then I use cin to get the user's choice. If the input is invalid, I clear the input buffer using cin clear and cin ignore to prevent errors. To handle each menu options, I use a switch statement. I choose switch instead of if else because it is more readable and organized for menu system. Option 1 calls enter data to add a new machine. Option 2 loads data from a file using load data from file. Option 3 display the result using the function I explained earlier. Option 4 compares the machines. Option 5 save a report to files. Option 0 exits the program with a message. For any other number, it shows invalid choice and loop back. The structure of this main function helps to control the whole program flow in a logical and repeatable way. That is all for my presentation. I have explained the function, display menu, display result, and main in terms of what they do, how they are structured, and why I use that format.
Now I will demonstrate how our machine failure rate program works. When we run the program, it shows a main menu with several options. First, we choose option 1, add new machine data. The program asks to enter the machine names, total operation, number of failures, and operating times in hours. After entering this data, the program calculates the failure rate and MTBF, then store it. Next, option 2, load data from file. This read data from a file named machine.csv. It loads all machine records and automatically calculate failure rate and MTBF for each one. Then, option 3, display failure rate and MTBF. Here the program shows a table listing each machine names, total operation, failure rate in percent, and MTBF. It gives a clear summary of all machines. Now, option 4, compare machine performance. The machines are stored from highest to lowest MTBF, so we can quickly see which machines are the most reliable. Lastly, option 5, save report to file. This creates a report in output result.txt listing all machine data in a nicely formatted way. And this is how the output result show. So in conclusion, our mini project successfully achieved all its objectives. In this project, we are able to apply program and technical requirement to create a system that allow users to input or load machine failure data, calculate the failure rate and MTBF, and compare machine based on their reliability. The project also includes a feature to generate and export a format report, which is useful for maintenance planning and documentation. This project also shows us how C++ coding software can be used to support real-world decision making in system reliability analysis. And that's all for us today. Thank you.